The scarcity of water is one of the biggest challenges facing rural India. Together with village communities, the Sehgal Foundation team works in water-scarce regions to secure and sustain local water supplies.
We have been developing various replicable and innovative models and also building the communities, capacity building and strengthening the village level institutions so that people can take charge of their own development. So in the water sector, we have developed some innovative and replicable models, of which pressurized recharge wells is one of the models, recent innovations, which has been recognized by Millennium Alliance. Now this project is an innovation which will help combat the problems of those areas which are saline and have salinity in water as a problem issue. Through this innovation, we intend to resolve the problem of water availability in the saline areas.
In schools that previously had no source of water, pressurized recharge wells extending above and below the groundwater table create fresh water pockets in saline water zones and make it possible for children to have clean water for drinking and sanitation purposes.
So we developed a high pressure recharge well. It's a very innovative model of creating fresh water pocket within saline groundwater zone. What we do is we simply collect rooftop rainwater during rainy season from our buildings and then channelize this water into a recharge well, which is under the ground going up to aquifers. At the same time, it also extends up to the height of the building. So this creates a huge amount of storage, and this amount of water can create sufficient hydrostatic pressure, and slowly this water percolates into the ground and pushes away the saline groundwater, which is actually higher in density. In normal conditions, this replacement will not take place, but because of this huge quantity of water stored in the recharge well, creates sufficient pressure to replace the saline groundwater and forms a small pocket of fresh water, which can be later exploited through a small hand pump and after passing through a biosand filter, because there may be some chances of biological contamination, and people can use this water for drinking and sanitation purposes. What we have experienced is that where groundwater has a high TDS value, total dissolved solids, going ranging between say 1500 ppm to 3000 ppm, this system is yielding good quality water ranging just 60 to say 80 ppm only. So it is as good as bottled water.
Rainwater harvested from the school rooftops creates hydrostatic pressure and slowly pushes aside any existing saline groundwater. This fresh water is extracted from underground with a hand pump, and a biosand filter removes the biological contaminants, making the water fit for drinking. Serving about 500 children in one school, this technology ensures local water supplies for drinking, sanitation and cooking of the midday meal. In addition, for use in schools, this technology can be replicated at the household and community levels and across semi-arid regions with inland salinity.